Now let's go to the software. This is the drawing board where you can make your circuit. You can lay out the components that you need for your circuit and make the connections between them using this left panel where you have the buttons necessary to make the circuit. So where are the components? This button is going to take you to the library. Library is a collection of devices where you have your circuit components and different packages for each component. So this is the symbol that is going to show up on the schematic, and this is the PCB design which is going to show up on the PCB layout after you convert your schematic into PCB. So package depends on the physical dimensions of your components. So you can select the suitable PCB design based on your dimensions. Also, you can create your own device and PCB symbol in the library. So let me select this LED to complete the circuit that's there. Once I select and say OK, it's going to come onto my cursor so that I can place it anywhere I want. I can use the right click to turn it and place it where I need.
Now for complex components or complex schematics, you generally can't have physical connections, so there's this tool called labeling, in which you can just right click, label, and you can name it as ground, and it'll automatically make the connections that are required. Which Sasura. Also, for all hobby purposes, generally you can download the Adafruit and the SparkFun libraries, and it's got a good collection of components that can be used for most purposes. And of course, as Archana mentioned, you can create your library, and that will be covered in the handout that will be given. So now, going back to the PCB layout is what we need, or front to the PCB layout is what we need. So now switching to the PCB layout, you can just go to File, switch to Board, and it comes. Now I have already placed the components here, but you can move it around. So right click, move it around wherever you want to place it. Okay, now just simple guidelines. Never have, these are tracks, right? Nets. You can just go by selecting over here, route. And for the other mill, we are going to use, since it is a single layered PCB that we are creating, we'll use the top layer. You can select the layers. Now there are many layers. There are many layers over here. I've selected all of these, and they all have different significance. But actually, for the other mill, we need only the dimension layer, pad layer, and the top layer. Of course, if you have a double layered PCB, you need the bottom and wires as well. So I'm going to just skip out this, just show you how it looks like. Yeah, this is something it looks like, and this is what actually the PCB miller would actually have taken into consideration. But I'm going to show all as of now. You see these small lines? These are the lines that represent the connections that you have made in the schematic editor right over here. And Eagle draws it for you so that you don't have to worry about connecting them. Okay. Another guideline is that these tracks should not be at 90 degrees. So if I'm drawing out a track, it shouldn't look like this. This is because the current at the edge over here at the corner is the rate of the flow is completely obstructed, and that this creates heat and noise because of the obstruction to the flow of electrons. So instead we should have something like this placed and drawn out. Also, the pads, these green color round circles are called the pads, and these pads, the diameter of these pads should be at least twice the size of the drill holes. And of course, now when you're laying out the tracks, at that time you should make sure, especially for the miller, that the distance between the two copper parts should be a minimum, the size of the minimum size of the drill bit. And for us, in our purposes in the other mill, in the Maker Lab, we have 1 by 64th of an inch the minimum size. And so if you want to measure the distance, you can just create this mark and you see at the top right that it says 0.011, which is not good enough because 1 by 64th inch is 0.015, so we'll have to change that. Okay, so once you have hooked up the circuitry, then there's one little thing you have to do, yet major in terms of its contribution to the PCB. It's called ground planing, the concept of ground planing. So you can just select a polygon tool over here and just map out your entire PCB. Again, it has to be, let's cancel this, change the layer and polygon. Again, you can map it anywhere you want, it doesn't really matter because you'll see why. Here we go. Oops. Again. Okay, so now we're just going to change some things about it. Signal name is something that you cannot change from here. Make sure that you change the isolation to at least a 0.016 and the name you give it through this, and then you go to ground. That is because if you're doing ground planing. And there's this button called rat's nest, and it just, once you click this, not a polygon. Okay, so I figured out I have to change the grid size to default values. Hopefully this should work now. Again, make sure it's the top layer. Of course, I need the polygon. Name it GND, and the signal name should be the same as the signal names that you've given to the components. If you do, of course, you go to the properties and change the isolation at least 0.016. Okay, let's hope this works. Yep. So you see what this has done. This ground planing concept is actually very important when you're dealing with RF circuitry, because in order for it to absorb the noise that is coming from outside, and also it maintains all the ground planes or all the ground levels at the same level of voltage, so that there is no virtual grounding that happens. And this is ready to print. Let's go to the other mill and see what kind of problems we will be facing. Pause. So this is the other plan, which is the software that is used to interface with the other mill. We're quickly gonna do file, or rather open files, choose the circuit that we just created, and we choose the 1/64 inch just to see how it maps out, and that looks about right. So you should definitely look at it properly so that okay, so in this part, if you see, it looks like it's sort of crowded, or rather it's merging. You should make sure that the copper tracks are not merging onto each other, like this copper track is different than this copper track. Similarly over here, there's a minute copper track coming from here, and that is different from this. And how you notice that is that these gray lines show the milling path that the tool is going to take. And so I think this looks about right. I have checked it.